Yeah, students. So we are continuing with permutation and combination. Look at this problem. How many 3-digit numbers can be formed using the digits 1 to 9? So if no digit is repeated, so repetition not allowed. Simple question. So let's look into it. So we are looking for 3-digit numbers. So let me write 3 positions. And what are the available digits? So the available digits are 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fair enough. Now same thing, this position can be filled in 9 ways, this position can be filled in 8 ways, this position can be filled in 7 ways. So this will give the answer as 9 into 8 into 7. So 504 ways. So this is method 1. So you can apply this also. Second thing is, there are 9 digits available and we are going to do the arrangement of 3 numbers. So this can be done in 9p3 ways. Please understand, there are 9 digits available and we have to do the arrangement of 3 numbers. So there is no repetition. So that can be done in 9p3 ways. So which is nothing but, please recall NPR formula. NPR can be given by n factorial divided by n minus r factorial. So this is the first thing I am telling you. So this can be written as 9 factorial divided by 9 minus 3 factorial, which is nothing but 9 factorial by 6 factorial, 9 into 8 into 7 into 6 factorial divided by 6 factorial. So this is cancelled. So I am going to get the same result, which is 504. Okay, students. So this is the method, regular method. Is there any shortcut for NP3? There is a shortcut for NP3. Students, you listen to this carefully. NP3 is there. So I am going to write 9 first and going to reduce the number till 3 times. I have to reduce the number. So we have to go by in the descending order. So 9, 3 is there. So 9 into 8 into 7. Stop there. So 3 times we have to do it, reducing the number. So 9p3 is 9 into 8 into 7. What if it is 9p2? Let me write 9p2 here. So 9p2 can be written as 9 into 8. Stop. Descending order, 9 into 8. How we are going to write 9p4? 9 into 8 into 7 into 6. Stop there. So this is the shortcut. It is better you know this also. So similarly, if we have 10p2, how we are going to write 10p2? 10 into 9. Stop. So no need of this formula at all. Directly you are getting this result. And this result is derived from this formula only. Actually, in this shortcut, we are applying this formula so that this denominator is dividing the numerator. So it is cutting the 8 factorial here. So into 8 factorial divided by 8 factorial we will get. So it is actually cutting. So don't worry about that too much now. So what is the method? 10p2 means 10 into 9. Stop. If it is 11p3, 11 into 10 into 9. 3 times you have to write descending order for 3 values. So this is about the first question of your exercise in permutation. Take down. How many 4-digit numbers are there with no digit repeated? Good question. So we need to form 4-digit numbers. Okay. Now, what are the available digits? So this you have to understand. To form any number, the only available digits are 0 to 9. These are the only available digits. So that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the available digits for us. So all the numbers in the universe are formed using these digits only. So, these are the basic numerical values. So, all our human the invention, I can say, has been done with these numbers 0 to 9. So, using 0 to 9 only, all other numbers are derived. So, this is the scenario. So, available digits are, there are 10 digits available, including 0, there are 10 digits. So, let us skip it. Now, we need to form the 4-digit numbers. Now, students, for the first digit I cannot put 0, because if I write something like this 0 to 34, this is not a 4-digit number, because 0 to 34 is nothing but 234, it is becoming a 3-digit number. So, you cannot put 0 in the first place, remember that, because if you put 0 in the first place, the resultant will be 3-digit number. So, what we have to do here, other than 0 you can put all other values. So, all other values means how many are there for us? There are 9 values available. So, this position can be filled in 9 ways. Now, this position 0 can come, no problem. So, 0 is coming and one of the values is used here. So, among this 9, one value is used. So, one value we are taking out, 0 can come in. So, that means 9 ways again. Reason is 1 used, 8 available plus 0. So, 9 ways. This position can be filled in how many ways? 2 are used already, 2 values are used here. So, this position can be filled in 8 ways. This position obviously can be filled in 7 ways. Why we are doing this? Because in the question they are telling no digit repetition not allowed. So, this is nothing but 9 into 9 into 8 into 7, 81 into 56. So, 4, 5, 3, 6 ways. 6 ones are 6, 48, 5 ones are 5, 40, yeah, 4, 5, 3, 6. So, this is the answer. Take down fast. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated? Simple problem. See, 3-digit even number. For the number to be even, the last digit must be, as I have already told you in the previous session, it can be 0, 2, 4, 6, 8. So, here the number can be 0, 2, 4, 6, 8. So, then only it will be a even number. So, 3-digit even number, 3 positions. This position can be filled in, you can take this, this or this. So, this can be done in how many ways? 3 ways, right? This position can be filled in, how many numbers are available? 1, 2, 3, 4, 5, 6. 1 is already used. So, this can be filled in 5 ways. Please understand, 2, 4, 6, 3 ways, one number is already used. So, we can't take one number here. So, I am left with 1, 2, 3, 4, 5 numbers. So, 5 ways we can fill this. This position can be filled in, 2 numbers are used. So, how many I am left? I am left with 4 ways. So, my answer is 60 ways. That will be the answer for this question. Find the number of 4-digit numbers that can be formed using digits 1, 2, 3, 4, 5 if no digit is repeated. Simple question, do it students. So this position can be filled in 5 ways, this position 4 ways, 3 ways, because no repetition, this is 2 ways. So my answer is 6 into 20, 120. So this is for the first question. So what about the second question? How many of these will be even? So we need to find the number of even numbers. Same logic, students. So 4 digit numbers are there. So to make it even, you know it, this digit must contain 0, 2, 4, 6, 8. So look for the available values. So I can take only 2 and I can take only 4. So this can be done in 2 ways. So one of the numbers is used. So how many I am left with? I am left with 4 because 1 is used. Available 5, 2 are used. Okay. So it can be done in 2 ways, I mean to say. So one number is used. So I have 4 more numbers. So this position can be filled in 4 ways. Now 2 numbers are used. So this can be done in 3 ways. 3 numbers are used. This can be done in 2 ways. Please understand. So I am going to repeat this. This position can be filled in 2 ways, 2 or 4. Only one number can come there. So one number is used. So how many left out? 4 numbers are left out, 4 ways, 2 used. So left out is 3, 3 used, left out is 2 ways. So my answer is 48 ways. Yeah, students, this is a very good question. This is an important question actually, kind of tricky. See, from a committee of 8 persons, in how many ways can we choose a chairman and vice chairman, assuming one person cannot hold more than one position? That means repetition is not allowed. One person cannot hold more than one position. That means repetition is not allowed. So that is the meaning. So solution. So I'll tell you the method 1. So obviously this position can be filled in 8 ways. Let us say this is chairman. So because the chairman is already placed, the vice chairman, he can't come because one person cannot hold more than one position. The meaning of this is without repetition. That is the meaning. So obviously this position can be filled in 7 ways. So 7 8s are 56. So this is the first method. So let me do the second method also. Normally students get confused and they will ask me this question. Sir, there is a choose here. So choose refers to combination, right? You are exactly right. You are not wrong with that. You are absolutely right with that. So choose represents combination only. So let us solve using combination also. So there are 8 people and 1 chairman, 1 vice chairman are required, right? So now students, listen to me carefully. 1 chairman can be selected in 8C1 ways and into 1 person is already taken up. So how many available now? 7 are available. 1 chairman is already made. So how many available now? 7 are available. So 7C1 for vice chairman also 1 person is needed. So my answer is 8 into 7, 56 again. So this way also you can do, but understand the problem, then you do it. If this was not given, then the condition would be different. The answer would be just 8C2 if this was not given. Because this is given, so we have to go by this method. How many words with or without meaning can be formed using the letters of the word equation? So this is available. So there are 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are available. Fine. Now students, please understand, with or without meaning. What is the meaning of that means? So let us say one word I will take C. C as a meaning. But what if I use AES? It has no meaning. So even though it has no meaning, it is one of the arrangements. That is the meaning of that. So the point here is, they are asking the arrangement of letters. Arrangement of letters. So what are the letters that are there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Of course, there is no repetition because you can use N only once. They are given here. You can use O only once. So same logic will apply. This position can be filled in 8 ways, 7 ways, 6, 5, 4, 3, 2, 1. So this is nothing but 8 factorial ways. You calculate the 8 factorial and keep it. Arrangement of letters. You have to keep the 8 factorial value, multiply and keep it. Students, read the question. It's a very good problem. How many words with or without meaning can be formed using the letters of the word Monday? So there are 6 letters available. Assuming no letter is repeated, of course we are not going to repeat it, okay. If 4 letters are used at a time, 4 letters means it is a 4 letter word. So how many available? 6 are available. So students, this position can be filled in 6 ways. This position 5 ways because no repetition. This is 4 ways. This is 3 ways. So your answer will be 6 into 5 into 4 into 3. Fair enough. Now look for the second one. You can take down later. Second one. All letters are used at a time. All letters are used means all the 6 letters are used. So that means 1, 2, 3, 4, 5, 6. So this position can be done in 6 ways, 5 ways, 4, 3, 2, 1. So what will be the answer? 6 factorial will be the answer. You follow? Now look at the third one. So I'm going to write the third one here. All letters are used, but first letter is a vowel. All letters are used, that means 6 letters are used. First letter is a vowel. So what are the vowels in this case? A is a vowel, O is a vowel, M is not a vowel, N not a vowel, D not a vowel, A, E, I, O, U. So Y is not a vowel. So that means there are only 2 vowels. So this position can be filled in 2 ways. Please understand. Because one number is used, so I am left with 5 letters. So this position can be filled in 5 ways. This is 4, 3, 2, 1. Fair enough? So this will give me 2 into 5 into 4 into 3 into 2 into 1. 2 into 5 4 is 20, 23 is 60, 62 is 120. So the answer is 240. So you only write the value of 6 factorial. Simple, please understand. I am going to repeat. 4 letters are used means 4 positions, available 6. So 6, 5, 4, 3, finish. All letters are used means 6 positions are open, 6 factorial ways. All letters are used, but first letter is a vowel. So how many vowels are there, students? 0 and A. So this is can be done, this can be filled in two ways. One is used already, so 5 left, 5, so 4 left, 3, 2, 1, like that. Simple. See another good question. Please read the question, all of you. In how many of the distinct permutations? The meaning of distinct permutations means different types of arrangements. That means this word is there now. I'll come to this word later. All the letters are arranged in different formats. So, distinct permutations means different arrangements of the letters in Mississippi. Okay, Mississippi. This is the word. Do the 4 I's not come together? So that means the I's are separate. Now for this question, total words when 4 I's not together can be equated to the total words, total possible words. Total words means total possible words. So total arrangement of words minus total words when 4 I's are together. So what is that? What is the meaning of this means? If they ask you how many girls are there in your class, so what you are going to do? You are going to tell indirectly. I am telling you, total number of students minus number of boys will give you total number of girls, right? So assuming there is no transgender, so assuming with that assumption, of course. So how many girls are there if they ask you? So it will be equivalent to total number of students minus total number of boys. Same thing is applied here. I's not together is equal to total words minus total words when 4 I's are together. Okay. Now total words. So how many total words are there? Let us look into it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So correct. So the 11 position can be filled in 11 factorial ways. And I have to divide something here because repetition is allowed. The reason I am doing this is, please listen to this. If I write, let us say INDIA, India, again I am going to write INDIA and tell you this I is coming here. Will it make any sense for you? No, because the both are same. So this repetition I am going to reduce by dividing it. So whatever the letters which are going to repeat, I am going to divide it. Now what are the repeated letters in this case? How many S are there? 1, 2, 3, 4. There are 4 S. So I am going to do it by 4 factorial. I, how many I are there? 1, 2, 3, 4. There are 4 I are there. So 4 factorial. Next, P is also there. P is repeated 2 times. So 2 factorial. This is about it. This is about total words. Minus total words when 4 I's are together. Please listen to this. So what I am going to do, I am put the 4 I's here. I. So this is one entity. And remaining I have 1, 2, 3, 4, 5, 6, 7. So total 11 are there. So 4 I's, remaining letters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct, perfect. Now students, when all the letters are interchanged, this 4 I's will also move together. So 4 I's together as an entity, they will move. So swapping is done in how many ways if you ask me? How many entities are there? This is single entity. 2, 3, 4, 5, 6, 7, 8. 8 factorial ways. And what are the repeated words here? sorry, repeated letters in this case. I we don't consider, because this is just one entity now. So what are the other letters that are repeated? S is repeated, 4 factorial, then P is repeated, 2 factorial, and they themselves, they will do in 4 factorial by 4 factorial, which is nothing but 1. So I am not going to write it. Please understand this. This is the important part. This is one entity. So this entity will move along with the other letters. There are totally 8 entities, 1, 2, 3, 4, 5, 6, 7, 8. In how many ways 8 entities will move? 8 factorial ways, divided by, what are the repetitions? 1, 2, 3, 4, 4 factorial, and P is there, 2 factorial. Clear? Into 4 factorial by 4 factorial, which is 1. Fair enough. Minus 8 factorial divided by 4 factorial into 2 factorial. So get the answer for this, all of you. So you should be getting 3381. Check out. Three three eight one zero. Yes, correct. 33810. Students, take down this question. Very important question for exam. In how many ways can the letters of the word permutations be arranged if the words start with P and end with S? Let us see how many total letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 positions, that means 12 letters. 7, 8, 9, 10, 11, 12. Okay, students. Now the sub question number 1 I am doing here. Words start with P and end with S. So these two values are fixed. We are not going to take them away. They are fixed. Now we are left with how many positions? We are left with 10 positions. So these are the 10 letters available. So they can be arranged in how many ways? You people know it. 10 factorial ways, right? 10, 9, 8, etc. Divided by, look for the repetition. So is E repeated? No. R no. M no. U no. T is repeated, of course. So 2 factorial. Repetition I have to divide, I have already told you. A no repetition. I no. O no. N no. So 10 factorial by 2. Okay. You get the value later. Don't worry about the final figure. I know all of you can do it. Second one, you see it. Vowels are all together. So what are the vowels in this particular case? Let us look for vowels now. E is there. U is there. A, I, O. All the vowels are there. No problem. Now I am going to lock all the vowels in one entity. Please understand. This entity will move. So this is a single entity. So this entity will move. Please know it. And how many positions I am left with? 5 are already taken. So total 12 are there. So 1, 2, 3, 4, 5, 6, 7. 7 other letters. Now students, totally how many entities are there, including this? 8. So this entire thing will move in the arrangements. So this can be done in 8 factorial ways. Any repetitions? Yes, there are repetition of T, we have already told you, 2 factorial. Into, inside this entity, how these 5 different letters are going to move themselves, how they are going to arrange themselves. Inside I am talking. they are going to arrange themselves in 5 factorial ways. 5 letters, 5 factorial ways. 5, 4, 3, 2, 1. So, this will give me 5 factorial. Okay. Calculation part, don't worry. Now, third, I know you can do the calculation. There are always 4 letters between P and S. So, let me write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the meaning of this? 4 letters between P and S. That means when I write P here, S here, there are 4 letters. That is the meaning. And what is the position of P and S? It can be anywhere. Please understand. So, when P and S are there, 4 letters must be there in between. Now, let us proceed here. So, let us start keeping P here. So, if I keep the P here, S can come here, right. So, this is one position. Second, I can keep P here, S can come here. You follow? So, this is the second position. Likewise, P can come here, S can go there. 3, hold on for a second, yeah. 4, this is also valid. 5, 6, so P and S are coming here. 7. So, like that, there are 7 positions available for P and S. You follow? So, 7 positions. Now, students, instead of P and S, I can put S and P, because there is no condition there. This is P and S, fair enough. This can be S and P. So, using S and P also, we can have this 7 counts like this. So, S and P, same thing. So, it will be total 14 ways we can do it. So, what is the 14 way we are doing? Keeping the P and S and P in position. Now, what will be the final answer? 14 into, in how many ways we are going to arrange the remaining letters? P and S are fixed here. P and S are fixed. So, how many remaining letters are there? So, total 12 are there, 2 are fixed. 10 factorial divided by 2 factorial. Total 10 letters are there, 10 factorial divided by